All right, let's get going. I'll
Okay.
share screen and we'll get started. Ooh. Well, again, welcome everybody to this evening's workshop webinar. If you are back from last week, good to see you again. And we're going to really get into no specific families or different genera for most of the rest of the workshops as we go along over the next couple of months. And I know that the Fabaceae, the legumes, is obviously a very important group. It's one of the most diverse families. I think it's something like third or fourth, something like that. And certainly in Iowa, it's in the top three. And it's very important, of course, ecologically as well, because of so many things, nitrogen fixation just being one. And of course, a lot of great flowers for pollinators to use, of course, as well. So I think this is a family that we ought to tackle. It's going to be difficult to get through, and we're not going to cover all the species, of course. That's just not possible. But we'll do what we can. All right. So again, here's a list of some of the websites that I use for photographs. Some of these are my own photographs, but most of them it's just easier for me to just go online and get some photographs rather than scan some slides. And I will say that Missouri Plants and Minnesota Wildflowers are probably the two most important ones that I use. So we're going to look at the Fabaceae. And if you remember, if you were here last week, we went through about 23 families or so and just tried to give people just a little bit of a sense of what to look for, what would be some good family characteristics to help you pin those families down. And the legumes, the Fabaceae was, of course, included. This is sort of looking at it a little bit different view than I gave last week. There's three subfamilies that are in the family. So it's really helpful, of course, to be able to recognize which subfamily. And they're pretty different. The Papillonoids, the first one here, is by far the most common and is the most, characteristic and flagship plant, because it has the papillonaceous flowers, the large, often large pea-like flowers that are highly modified in terms of the corolla into specific functions, really. The 5 petals here are given different names. The standard or banner is the large petal up on top that serves as a attractor, a signal to the pollinator. Then there are a couple wing petals that are used for landing, and then a couple keel petals down below that are usually fused along the bottom side and enclose the stamens. The Papillonoids and the Mimisoids have corollas that are a little bit more radial. In other words, this one is strongly bilateral. There's only one place you can draw a line through here and get two equal halves. The Papillonoids are sometimes they're bilateral, strongly bilateral. Sometimes they're more like this, nearly radial. And the Mimisoids are usually radial, but they have a corolla that's much less conspicuous. Their corollas, when I say corolla, I have to keep reminding myself to help with terminology. I'm assuming there's some beginners. So corolla is a term we use for all of the petals. So all the petals make up the corolla, and in the Mimisoids, again, the corolla and even the sepals, which is the calyx, are reduced somewhat and not as conspicuous. As you can see in this example here, it's really the stamens that really draw your attention. The one thing that really unites all of these subfamilies together, though, is the single carpel that's in a simple pistil. These flower diagrams right here are just a kind of a nice summary way. I showed you these last week. Nice way to summarize what the flower looks like, how it's put together. The outer bracts here, these are the bracts here, these things out here, then the petals are these things in here. Same thing here, these are the sepals, these are the petals, sepals, petals. All these little round little eights, small little eights are stamens. And then this thing in the center is the symbol for a single carpel, which is, again, also can be described as a simple pistil. And that's again where the ovules are. It's where the seeds are going to be formed. But that simple pistil, single carpel, is common to all three groups. You can see that the Papillonoids and Mimisoids also have a hypanthium as a way to sort of separate them from the Papillonoids. And a hypanthium is what you see in a flower that looks like this. It's that purple area I just highlighted there. It's basically just a little floral cup. It looks like a little cup structure. It's formed by the fusion of the lower parts of stamens, petals, and sepals, all fused together. And of course, this little floral cup, has walls that completely surround then the ovary, which we see right here. So the hypanthiums in Fabaceae are not strongly developed, but they are there. Now the stamens are something that are unique over here in the Papillonoids. In the Papillonoids, the stamens are either 5, 10, or most of the time, I use the symbol 9+1, which is what we see here. There's 10 stamens altogether, but 9 of them are fused together. These 9 right here are fused together, and one of them is not fused. It's kind of hard to see the stamens though, again, well, at least in this group, because again, they are sort of enclosed by these keel petals here. More than 95% of the Papillonoids are end fixers. That is, they have nodules on their roots and in combination with Rhizobium bacteria fix in. 85% of the Mimisoids are end fixers. The Papillonoids are much less. Papillonoids are only about 40%. The other thing that's important is the inflorescences, how the flowers are arranged. And in the Papillonoids and the Papillonoids, the inflorescences can be a lot of different things. They're often some type of raceme or some type of spike. But in the Mimisoids, they're a little bit more distinctive. In the Mimisoids, what they are is a very dense head-like cluster. In fact, that's what we're seeing right here. This is not a single flower here. This is a group of a whole bunch of flowers, probably 70 or 80 flowers here, each of them with anywhere from maybe 5 to 10 or 12 stamens. So it looks like there's you see all these stamens. It's because the stamens, again, are so conspicuous. They're very long and exerted out of the much smaller corolla. All of them have either a legume, a pod, and we'll talk more about those. This group of Papillonoids have a fruit that's called a lomint. We'll see examples of these. The legume, again, is supposed to be the characteristic fruit of this family, hence the old name Leguminosae, but that's really not very true. A lot of the Fabaceae do not have a legume. They have a pod instead. And just a quick explanation here. A legume is a dry fruit. It's made of just one, again, carpel, and it's dehiscent, meaning it splits apart on its own, in theory. It splits along 2 different lines, and that opens the fruit up for the seeds to come out. So that does occur in some, but in a lot of cases, that fruit does not open up by its own. It's an indehiscent fruit. It's still a dry fruit. It's still formed from one carpel, but it's indehiscent. And so what some people are doing is they're using the term pod to describe that. Now, pod really does not have a really good official definition. If you look it up in the botanical glossary, and by the way, I'm going to send a couple of links, or maybe actually send the glossary to Lance so that he can send it to you guys, because you really need to have a glossary, to help you with some of these terms. And pod is not really well defined any way. In fact, it's kind of said it kind of depends upon how you want to use it. But we need another name for a fruit type in this family that represents the indehiscent fruits, and so pod works for that. Okay, and again, if you have any questions along the way, just throw them into the chat, and Lance will tell me what they are. As far as vegetative things, most of the Fabaceae, almost all, have compound leaves. There's a few that don't. They're either pinnately compound or palmately compound, and we'll see examples of those. They're almost always alternate. Opposite leaves is really rare. Sometimes the leaves are basal. Again, that's not very common. And there's usually stipules, and we'll see plenty of examples of that. So there are some vegetative characters that, again, kind of help to combine the family. So in Iowa, there's about 36 genera. Now this is based on Eilers and Rosa. And if you don't know what Eilers and Rosa is the standard reference that we use for the Flora of Iowa. It came out in 1994. In 1994, it was a pretty good list of all of the species that were native or naturalized in Iowa. And it gave a little bit of information about their distribution, how frequent they were or are. And of course, it gave you what we in Iowa should use as their correct scientific name, what we call the nomenclature. It's badly outdated. Now, of course, since nothing's been done with it since 1994, it needs to be revised. But this is what we've got. And so it's a starting point. So based on Eilers and Rosa, there are 36 genera, about 89 species. 59 of them are native, as you can see, and 30 are non-native. I didn't really realize this, but 18, over half of the genera, only have one native species. So in a way, that really helps you in learning these species, because usually genera, again, have larger differences from one genus to another. And so it's a little easier if you learn the characteristics for a genus for these 18, then you know that species, at least that native species. There's other genera here that have 3 or more species, or these, and there's these 4 here have two species. Again, I'm just talking the native species. And that's all we're going to be dealing with tonight. I'm not dealing with any of the non-natives. So in your packet, you have 2 tables, and this is what I did last year as well. One table is going to go through and show you the genera that have native species. These are the ones that you want to learn. The genera that have native species, and I have a little code that will tell you which subfamily that genus is in. Most of them are in the Papillonoids, of course. There's about 5 genera in the Papillonoids and 2 genera in the Mimisoids. Then you have another big table, and this took a long time to put together. Well, both of them took a long time to put together, but this one is going to list all of the native Fabaceae species and give you basic information on their status, how they're seen in Iowa, native, or if they're listed, nomenclature that is currently in use for them, what their habitat and what their biogeography is. We'll take a look at that probably next. That'd be the next thing to look at, because this gets into starting looking at some of the species. So I'm going to pull up that those tables. And so again, this is table 1. It has all of the genera in it here. Now, I don't have time to go through all this in great detail. I'm going to try to highlight some of the things that are important for these. And then over here on the right, I tell you how many native species and exotic species there are. So for Amorpha, that of course includes the lead plants and indigo bush. The thing that's really helpful there is that the lead plants have a corolla that's really reduced to a really small flower. They're a papillonoid, but they don't have that complex flower with the banner and the wings and the keels. They're reduced to just a single banner petal. That is really easy to separate then. There's 3 species in this group from everything else. Amphicarpa is a plant that twines and grows and climbs on other plants, as it says here, stems climbing and twining, but it's not really a true vine because it does not have any tendrils. Now it's it's kind of complicated. This is an easy way to separate it from others. It's got two kinds of flowers. And one kind is called a chasmogamous flower. That's a flower that's very pretty and showy. It has big corolla that's attracting pollinators. That's your normal typical flower that you think of. And those chasmogamous flowers are in racemes. It also has cleistogamous flowers, and cleistogamous flowers are really small and inconspicuous. You don't even probably know they're there. They don't have any petals. That's what this means, apetalous. And those flowers are much lower down on the plant, way at the bottom of the stem. Sometimes they're even down in the soil. Apios, groundnut, that's another one that's climbing and twining, but again, it doesn't have any tendrils. It has a milky latex. We're going to look at these two in more detail, as well as the amorphas. Now, the astragalus, we're not going to. There's 8 species of astragalus in Iowa. I didn't get, there's not enough time to do everything, so I left them out. But 5 of them are listed. And that means if they're listed, they're not species you're probably going to see very much of. There's only 3 that are really very common, and those are Astragalus canadensis, Canada milkvetch, Astragalus crassicarpus, the ground plum, and if you're in the Los Hills, Astragalus lodiflorus, the lotus milkvetch. The thing that is helpful for recognizing this genus, and especially separating it from Oxytropis, the local weed, which is going to resemble somewhat because both of them can have basal leaves, is that Oxytropis has a keel here that has the tip of the petals. The keel petals are tapered to a pointed beak, very conspicuous pointed beak. And in the astragalus up here, as it says here, the keel petals are obtuse or rounded at the tip. They don't have that pointed beak-like look. We're not going to cover Baptisia either. I didn't get to them. There's 4 species listed in Iris and Rosa, but one of them, Baptisia tinctoria, was a mistake. It shouldn't have been listed. It's not in the state. And another one, Baptisia australis, that one's kind of iffy as to whether it's really native in Iowa or not. It's hard to say for sure. We're going to talk about all of these, so I can skip over them. We're going to look at Cassia, Cercis, Gamacristic, Cordylaria. Not going to do any of the dahlias. There's 5 species of dahlia in Iowa. One of them is listed, and then there's 2 others that are really common, of course, Dahlia purpurea, purple prairie clover, and Dahlia candida, the white prairie clover. Those are pretty distinctive. Here's some good things, again, to help you separate them from other things. Again, these characteristics here, these are diagnostic characteristics. If you read through these and compare them with other genera, you should be able to see things that will definitely separate each of these genera from everything else here. We're going to do Desmanthus and Desmodium and all of these in through here. Not going to do Lespedeza. There's 5 species of Lespedeza in Iowa, and 2 of them are listed, and only really just 2 others that are likely to be seen: Lespedeza capitata, the round-headed bush clover, and Lespedeza violacea. We're going to do Oxytropis, Pediomelum, Ceruleum, Schrankia. We're going to do all of these. There's only one native trifolium. The clovers, there's like 9 non-natives, and the one native trifolium is Trifolium reflexum, and it is, we'll see what it is when we get to this table here coming up. So here's the other table. Again, lists all of the species and shows you all this great information, information about habitat. Now this first column, if the Flora of North America had been done for Fabaceae, the Flora of North America name would be right here, but it's not done yet. So we don't know what Flora of North America is going to say is the correct name. I'm sure in this case, Flora of North America is going to say Amorpha canescens is the name here, but I'm not going to put it in there until the flora is actually out. So this column is showing again what the nomenclature is according to Flora of North America, and then what the status is and what the coefficient of conservatism is. These are the revised coefficients, and if you haven't heard of these before, it's just a number from 1 to 10 that basically tells you what the affinity that species has for highly pristine, high quality natural ecosystems. So the higher the number, the more indicative then that species is of those places. The letter here is either an L, M, or H, meaning low, medium, or high confidence in that number being right. The maps over here, it takes a lot of time to put these together, so I hope you can use them and appreciate them. If you're doing a restoration, want to know what to plant, then you better be looking at these maps. These maps show you as far as we can tell, well, mostly the ones that have the red counties come from Paul Christensen's Iowa Prairie plants. And so that one it strives to look at what the native range was. So again, you don't want to plant anything unless it was something that was native to wherever you are. So this column again is looking at the biogeography in Iowa. And then this one, of course, these are the BONAP maps, and it shows you the bigger picture of what's that species distribution in the entire country. If a plant's not in the Iowa Prairie plants, then I put together these little dot maps using BONAP or using the Iowa Natural Areas Inventory, as done right here. For this particular plant, it's astragalus because it's an endangered species. And when you see an endangered species or a listed species, it would be threatened, endangered, special concern, or presumed extirpated. I dig up the information that tells you sort of what makes it that way. And so astragalus insurgens, we can see there's only 2 counties that it's ever been seen in. In the Iowa Natural Areas Inventory database, there's only 4 known populations, and only 2 of them have observations that have occurred since 1980. So that tells you that, you know, this species is pretty close to probably being gone. We can't say it is yet, but getting there. So that's what you're going to find here, all of that good information. And some of these, I draw these lines in here to help show you sort of where you'd expect to see the species and where you wouldn't. The red counties are over here. So this is where you could plant it. This is where you shouldn't plant it. All right, so yeah, I went through, this is all the native species. We were going to look something up, or I forgot what it was now. All right, well, again, we don't have time to go through all of these, so I just wanted to let you know what this is so you can make the best use of it. And then at the bottom here, there's going to be some references that tell you where a lot of this information came from. Yeah, right. That's a long table. There we go. And so again, if you forget what I said, the fields, the columns basically are listed right here. All right, are there any questions? All right,
I don't see any in the chat.
Okay, well, let's get started. We're going to look at a few of these. Again, we're not going to be able to look at everything. Let's start here with some of the genera that just have one native species. So what you see here, I'm going to compare these 2 here. This is partridge pea, which is Chamaecristae. That's the genus it's in, Chamaecristae fasciculata, with Cassia, Marilandica, Senna. We'll say real quick that one native species, and others most only list one species of Cassia to begin with, but we know now, and this is one reason why Eilers and Rosa needs to be revised. There's lots of these. There is another species of Senna that has been discovered in Iowa, Cassia hypocarpa, which is, presumably it's not native to Iowa. It's come in probably on some seed mixes. I know there's, it's been, I think, discovered in Dallas County and maybe over in Johnson County. So this is showing you, I guess, some of the main features to help separate them. What usually I try to do is put a picture and it kind of just shows the plant as a whole, and then some of the important things. I did this for these 2, but this is the only slide that has this. there's some things that separate these two. The size of the leaflets is one thing. I didn't put that in here, but the size of the leaflets does help somewhat here. These leaflets on partridge pea tend to be smaller than over here on senna. But what I have listed here is the stipules. That's these things right here. You can see the stipules here. What a stipule is they occur as pairs. So two little leaf-like structures. We call them bracts. A bract is a term that means something that comes from a leaf. It's a modified leaf, but it's very, very small. It's really not functionally a leaf because it's really not there for photosynthesis. But what a stipule is, again, is two of these little bracts that occur right at the base of where a leaf is attached to the stem. So right here's a leaf right here attaching to the stem, and there's a stipule there and there. In cassia, or excuse me, in partridge pea, the stipules are larger. In senna, they're a bit smaller. The fruits. Okay, so here's a fruit. So this is a legume because it is dehiscing on its own. In senna, the fruits are weakly dehiscent at the best. And so maybe a legume if you give it enough time, but otherwise, if it doesn't dehisce, then it should be called a pod. And then the other thing is the stamens. If you have the flowers, you can look at the stamens and really see a big difference here too. In partridge pea, there'll be 10 stamens, but there'll be two different sizes of them, two different heights, in two different groups in a sense. Over in senna, there are 7 stamens and 3 staminodes. So there's 10 sort of stamen-like structures, but 3 of them, since they're staminodes, what a staminode is, it's a stamen that's not fertile, a stamen that does not produce pollen. And so it's really not doing anything that important. Sometimes staminodes do provide nectar, but I don't think these do. So there's only 7 that are producing pollen versus 10 over here. And again, over here, though, there's 3 different sizes. All right, the next group here is some of our trees. So we're looking again at Papillonoids and the other 3 genera here. Redbud is Cercis canadensis. Honey locust is Gleditsia triacanthos. And Kentucky coffee tree is Gymnocladus dioicus. So you're going to, again, identify these because they're Papillonoids. And again, one thing about Papillonoids is that except for this exception right here with redbud, which has simple leaves, Papillonoids usually have, often will have twice compound leaves. Sometimes they'll have once compound leaves. And so here's a good picture of what we're talking about. Both of these are leaves. This whole thing is attached to the stem as one leaf. Same thing here. Compound leaves are usually big because what happens in a compound leaf is that the leaves blade area that we see right here gets divided up into many, many, many small little segments called leaflets. And a twice compound leaf, again, looks like this one right here, because right here is where the leaf would be attached to a stem. And so there's a petiole right here that attaches it to the stem. And then going beyond that petiole, there's a rachis, but this is called the primary rachis because it's the one that's an extension of the petiole. The leaflets are not attached to the primary rachis. There's a secondary rachis that branches off of the primary rachis. That's where the leaflets are attached. Since there's a primary and secondary rachis here, it's called twice compound. If we have this leaf, the primary rachis is the only rachis we have, and the leaves are attached to it. So it's once compound. So again, honey locusts can have both on the same tree. The twice compound are usually coming off of bigger and longer shoots, whereas the once compound leaves are usually coming off of shorter spur shoots. Kentucky coffee tree always has big twice compound leaves. Some other things, of course, are that honey locust has these thorns, and they can be gigantic and they can be branched, because what a thorn is a modified branch. The flowers on both the honey locust and Kentucky coffee tree are kind of greenish yellow and don't look anything like the pinkish, purplish colors that redbud has. In fact, redbud is it's a sesquipenoid, but it has a flower that is sort of like a papillonoid. The fruits here, redbud fruits is called tardily dehiscent. That means they will dehisce, but it takes quite a while. So a legume eventually, I guess. In the honey locust, they are called legumes with age. That again, give them enough time. As they get older, they start to split open. And same thing with the legume here. It's a legume, but with age, because it takes quite a while. All right, let's take a quick short break, 3 or 4 minutes, just give you a chance to stretch, and we'll come back and take a look at the rest of these slides. I think there's about 10 slides left.
We did have one question.
Okay, I can deal with that.
Any tips for differentiating between Cassia marylandica and Hebecarpa?
Cassia marylandica and Cassia hebecarpa?
Yeah.
Yeah, those two are fairly similar, so it's not easy. But what I have found, and what I've asked people to do when they want me to help them with this, is see if you can get some seeds, collect some fruits, and send me the seeds, because the seeds are one of the easiest ways to separate them. You can separate them on the basis of the flowers by looking at the, I believe it's the styles and stigmas and the amount of hair that's present there. That's another characteristic. Sometimes those characteristics are a little bit subjective. So, sometimes it's, well, which one is it? I know there seems to be one more too. I think it might have something to do with the glands, the nectary glands that are on the leaves, on the petioles, the size of those. Yeah, it's the shape and size of those glands. That's another characteristic that separates them. The sesquipenoids, by the way, since we're talking about these two, the sesquipenoids often have, and this is unlike the other two subfamilies, the sesquipenoids often have these nectary glands that are associated with the leaves, not the flowers. So what the heck are they for? Why would you be attracting a pollinating insect to the leaves? Well, you wouldn't be, of course. These nectary glands are there to attract ants. And there's probably some type of mutualistic relationship going on there between the sesquipenoid and the ants. I'm going to grab something to drink here, and I'll be back in just a bit.
Hey, Lance, can you hear me?
Yeah.
I don't know how to send, this is MJ, and I don't know how to send a chat question. I typed it in, but I can't make it go.
Oh, okay.
Just hit the return.
I don't see the,
Yeah, just hit your, yep.
Nothing, I don't think anything happened.
Well, when you type it in, We've been
Okay,
talking.
okay, I'm just asking about how prairie plantings, there's so many plantings all over the state and they're getting a lot of different species in them, how that might be affecting the coefficient of conservation or the conservation coefficient.
I will I'll start the video and answer that.
What'd you say?
I will start the video here. I'll start my camera so you can see me. I'll start the camera and take that. So the question is, because of the enormous amount of restoration, reconstruction, mainly reconstruction, because that's what we mean when we plant, that's going on, how does that affect the coefficients? So when we were doing and assigning coefficients of conservatism, we had to always be thinking about ruling out any evidence or anything we saw in reconstructions or plantings. We did not let that influence what our thinking would be for the coefficient, because we know exactly like you would think, those are species that someone wanted to plant, and they got some seed and they planted the seed and it's there it is growing. We did not, again, I would not try to use anything that I've seen in a reconstruction to help guide my thinking. It always has to be what we've seen in natural populations.
But I guess my question was more not how it affected you, but the fact that it's based on the habitat or the quality where it's growing, and yet you've got plants growing in these reconstructions that are basically fake, and here are these plants that might be conservative otherwise. I mean, it's just sort of messy.
Exactly. I mean, you could have some, and a lot of people do have 8s and 9s growing in a reconstruction that is just a few years old, is really an early successional type of environment. And again, if nature was doing it, it probably wouldn't be like that. You would have more low conservative species, because those are the ones that usually do the best in early successional stages and would be the ones to find that site, find the disturbance. So, I mean, what does it mean? I mean, it doesn't mean you couldn't have success, and things will grow where they will grow. If there's one thing I've learned about plants in 35 years, is that you can't really predict much of anything about where a plant might grow and where it won't grow, if they have a chance. So I mean, all those species, certainly have some capacity to establish and grow, and they do that in a planting. What would probably happen, I guess, if you give a reconstruction enough time, is you might start to see some changes in the species composition that would be maybe predicted or would be reflected by what the coefficients are. But as competition becomes more intense, that the higher conservative species are going to be the ones that stay in there. The low conservative ones aren't going to, because the low conservative ones aren't as competitive. Is that what you're thinking?
Close.
Okay.
Thanks.
All right. So, let's get going. We got some more slides to look at here. So let's look at the next slide here, which is the Mimisoids, the 2 genera of Mimisoids, Desmanthus illinoisensis, the Illinois bundleflower, and in Alexandria rosa, Schrankia natalii, sensitive briar. That's now mimosa. Well, in some floras, that's now in a genus called mimosa. Again, we'll see what happens in FNA. Well, both of these, again, are going to look pretty similar because of the twice pinnate compound leaves. And that's the other thing about Mimisoids is that they almost always have twice pinnate compound leaves and lots of small leaflets, and also leaflets that are able to respond to touch or to light. In other words, exhibit leaf movement, leaf tropisms. And they're always, of course, going to have these flowers that are where the corollas are really reduced. You really can't see them very much. All you see is all these stamens. But again, you're looking at an inflorescence that may have 70 to 80 flowers. Each one of these, in Desmanthus here, each one of these flowers has 5 stamens. So the reason there's a whole bunch of stamens here is because there's a whole bunch of flowers, all in a tight cluster. The biggest thing you can see right here, obviously, to separate the two, is that sensitive briar is very prickly, has lots of prickles on the stem, has prickles on the fruits too. Whereas there's no prickles anywhere on Desmanthus illinoisensis. And Desmanthus illinoisensis is usually going to be more common. You look at the map, which I'm doing real quick here. Schrankia is pretty limited in Iowa to just the far southwest. And there's also a record of it way down in southeast Iowa. So that's not really as likely to be seen. All right, now we're going to jump into some Papillonoids. We went through the 5 genera of Sesquipenoids and the 2 genera of Mimisoids. So here again are some Papillonoids that each have just one native species in the genus. There's Oxytropis lambertii right here, Cordylaria, Sagittalis, and wild licorice, which is Glycyrrhiza lepidota. So what can we use to separate these? Well, again, I'm just going to try to point out some gestalt things here as we look at these. First of all, in Oxytropis, again, remember we have these beaked keels that I was telling you about before. There's a nice picture of one right here. So here's the banner petal. Here's a wing. Here's a wing. Here's the 2 keel petals. Remember, the keel petals are fused together along the lower side. And that's, again, is where the stamens are. But we get this sort of beak-like structure because the keel petal, the ends of the keel petals are kind of pointed. And in Oxytropis, the leaves are almost always, all the leaves are basal. There's really never an upright stem at all. Sometimes there might be a leaf, one leaf that's coming off a little bitty tiny short little stem, but I've never really seen that. So all basal leaves. Both of these are going to have an upright stem that have leaves coming off of the stem. And in Cordylaria, we've got these stipules here that are very distinct, very large. And the bottoms of these stipules continue down the stem as a wing tissue, some tissue that forms these wings. So again, and it goes all the way down to the next node right here. Here's another leaf right here. And here's the stipules that are attached at that node. And again, the wing going down from that point. So that's a very good characteristic there. For Glycyrrhiza, probably one of the best characteristics, they've got really good papillonaceous flowers, like you'd expect. But you see here that the fruits are very prickly. And I think we've got legumes here. Yeah, here's a legume. So again, I tried to show examples of what happens with the fruits. And so if you see a fruit that's opened up here, we can assume that opened up there on its own, and that is a legume. Legume here as well. Next group, next slide, is again some more genera with just one native species, Papillonoids. Here we're going to be comparing here is hog peanut, Amphicarpa bracteata, with groundnut in the middle, Apios americana, and American vetch on the far right, Vixia americana. All of these, I put these all 3 together because all 3 of these do some climbing, scrambling, we sometimes call it, climbing and scrambling over top of other plants. In the descriptions, or in the descriptions of the genus, you'll see a term I use called trifoliate. And so trifoliate always means a compound leaf with 3 leaflets. But you can have a pinnately trifoliate leaf or a palmately trifoliate leaf. And this is what we see. This what you see right here for hog peanut is a pinnately trifoliate. What makes this pinnately trifoliate is that the terminal leaflet right here has a petiolule, that's the stem of the leaflet, that's longer, easily much longer than the petiolules of the lateral leaflets. So, and you can really see it here. So anytime that happens, that then is described as a pinnately trifoliate leaf. A palmately one would be, we'll see an example with Baptisia or with Trifolium. They're basically all the petiolules are very short and the same size, or else there isn't a petiolule at all. The leaflets are sessile. All right, so the trifoliate leaves, of course, are going to really distinguish Amphicarpa here from the rest of these. Apios has pinnately compound leaves, but has either 5 or 7 leaflets. And Vixia over here has many leaflets. And of course, now Vixia is different from these two in the sense that it is a scrambler. It climbs on other things, but this is a herbaceous vine because it has true tendrils. Now, this is not Vixia americana. I couldn't get a good picture of a Vixia leaf. So this is Vixia villosa, a different species. It's a non-native species. But this is what we mean by tendrils. What the tendrils are is they are modified leaflets at the tip of the compound leaf. So another thing that's true here is Vixias are always going to have an even number of leaflets, because the terminal leaflet and even some of the other leaflets are modified to form a tendril, which is, again, a structure that's used to wrap around other vegetation and help support the plant as it scrambles over and climbs up things. Another thing with Vixia I want to point out here vegetatively is you look at these stipules down here, very conspicuous stipules and very persistent. So the one thing about stipules I need to tell you is that almost all the time Fabaceae plants have stipules at the beginning, but they're not always persistent. Sometimes the stipules are what's called caducous. That means that they fall off before you really can make much use of them. But these are pretty persistent. They'll be on the plant. And you see that the stipules are very elongate and they have these 2 big teeth down here. This is a very handy thing to help separate Vixia americana, American vetch, from another plant we're going to see in a little bit, the vetchlings, which are also climbing plants and have tendrils too. The difference in their stipules will help you separate them vegetatively. But we don't have that slide quite yet. The next one is going to be the, now we're looking at some genera with 2 native species. And what we have here are the prairie turnip and the silverleaf scurf pea. Both of these are in Pediomelum, the genus Pediomelum. And then as far as Eilers and Rosa goes, the one on the far right is scurfy pea. That's Pediomelum tenuiflorum. There's another Pediomelum native species in Iowa, Pediomelum lanceolata, but that one is one you're never going to see. It is presumed extirpated. There's only 3 populations that were ever found, and 0 of them have been seen since 1980. So the only Sorelidium is the genus here. Sorelidium we have is scurfy pea. But put them all together because they all have palmately compound leaves. So a palmately compound leaf is a leaf that has, again, its leaflets all attaching to a common point. We see here in prairie turnip, we see here in silverleaf scurf pea, and we can see 3 leaves here. Now we can see 6 down here, 5 here, 3 here. So again, the number of leaflets can vary. But if there's 3 or more, it's a palmately compound leaf. We might know, again, this one right here, if the petiolules are all the same size, and it looks like they probably are, this could also be called palmately trifoliate. So it's pretty easy to distinguish these again because of the differences in just the leaf color between prairie turnip here and silverleaf scurf pea. There's a lot of dense, short little silvery hairs that cover the leaves in silverleaf scurf pea. The flowers are a little bit smaller in silverleaf scurf pea. They're bluish, so they look a little similar to prairie turnip here. Prairie turnip is going to senesce. I was mentioning this before we got started, that this is why it's one of my favorite plants. It will completely senesce and dehisce at the base of the plant when the seeds are mature and it's ready to disperse seeds, so that it will be able to tumble with the wind and blow across the prairie and disperse seeds that way. These silverleaf scurf pea is not going to do that, or neither is scurfy pea. Another common name for scurfy pea is wild alfalfa. All right, here's the two Lathyrus that I was talking about. So these two are herbaceous vines. I have a leaf here of Lathyrus venosus, veiny pea, that shows, again, the tendrils at the tip of the compound leaf. Here's the stipules on veiny pea, Lathyrus venosus. Here's the stipules on marsh vetchling, Lathyrus palustris. You don't see those two jagged teeth sticking out here along the margin that Vixia americana has. So what are some things to separate these? Well, the stipules, for one thing, because of the pictures, you can't get always good scale pictures, but although they look similar size here, the stipules in veiny pea are usually about 1 to 4 millimeters wide, and the stipules in marsh vetchling are larger, 4 to 10 millimeters wide. Usually veiny pea has 8 to 14 leaflets, where over here in marsh vetchling, there's mostly 6 leaflets. And then the inflorescences over here, the way the flowers are arranged. In veiny pea, the inflorescences are these pretty dense racemes that can have 8 to 20 flowers in them. You can see them right here, some of them right here. Where over here in marsh vetchling, here's a raceme right here. They're much more open and only have 2 to 6 flowers. And then finally, I put a picture in here of the calyx. This is the calyx. The calyx in veiny pea is pubescent, is hairy. There's some hairs right down on here. Hard to see those, but they're there. And the calyx over here is glabrous. All right, here's some familiar ones, right? We've got now a genera with 3 native species or more. This one just does have 3. So we've got Amorpha here, and our Amorpha canescens, Amorpha nana, which is an endangered species in Iowa. Well, let me see for sure which one it is. Get it right. It is threatened, a threatened species. There's 24 populations known, and 11 of them have been observed since 1980. And then Amorpha fruticosa on the far right, which is a larger shrub. All of these are considered to be at least semi-shrubs. In your handout, in table 1, I use the term suffrutescent. Suffrutescent means that basically that the base of the plant tends to get kind of woody, but the upper part of the plant stays herbaceous. That's definitely true for lead plant and fragrant false indigo. For wild indigo, the whole plant gets woody. It's a full-blown shrub. So here you can see that characteristic I was telling you about. The corollas are just really reduced to just a single small and somewhat inconspicuous banner petal. You see that here on lead plant, you see that here on Amorpha nana, and you can kind of see that here on Amorpha fruticosa. So very small flowers. What separates them then otherwise? Well, so for separating these two from wild indigo is the fact of size, basically. These are, again, semi-shrubs at the most, no more than 1.5 meters tall, whereas wild indigo can easily be more than that. It's usually always over 1.5. Also the size of the leaflets. So again, these two over here have leaflets that are about less, well, they're less than 1.5 centimeters wide. Whereas over here, these leaflets, you can kind of see they're quite a bit larger. These leaflets are more than 1.5 centimeters wide. So that'll separate these two from this one. Of course, these two also grow in drier prairie habitats, and wild indigo grows in damp environments. What separates Amorphocanescens, the real common lead plant, from the more rare and less likely to be found fragrant false indigo is the way the racemes are clustered. So the racemes are the inflorescence. Again, it's the way the flowers are arranged. We see 1, 2, 3, 4, 5 racemes clustered together at the tip of this branch, or the tip of this stem. In fragrant false indigo, the racemes are sort of solitary. Also, the calyx tube. Here, the calyx tube is pubescent in lead plant. I tried to find a picture of it. You can see here, the calyx tube. You can see it right here where I'm pointing. That's the calyx tube right there. It's glabrous. They do look somewhat alike, just gestalt-wise. So you do have to take a closer look. Next one is some desmodiums. Now there's more than 3 desmodiums in Iowa, but these are the 3 they're most likely going to see. And so the 3 that you should learn. Desmodium canadense, which is showy tick trefoil, Desmodium illinoisense, Illinois tick trefoil, and Desmodium paniculatum, panicle tick trefoil. These 2 grow in prairies. Panicle tick trefoil is more likely to be in more of an open woodland, closed savanna, a little bit more shade. So one way to separate Desmodium canadense from these other 2 right away is to look at the trifoliate leaves. Again, so these are trifoliate, pinnately trifoliate, again, because we have the terminal leaflet has a little bit longer leaflet stem than the side ones. But what you see here is that these 2 over here have a petiole that's pretty long. In fact, it's longer than the petiolule of the terminal leaflet. This petiole, which is the stem of the entire leaf, is longer than the leaflet stem, which is called the petiolule that we see right in here. That's not the case over here. The petiolules of the terminal leaflet are longer than the petioles. Another helpful thing is Desmodium illinoisense has always got a lot of hooked hairs on it. Now, as a whole, Desmodiums have hooked hairs, little hooked hairs. That's a feature that you'll see in table 1. But they're really hooked and much more able to grasp onto things, especially your clothing, in Illinois tick trefoil. Also in Illinois tick trefoil, the stipules, get my pointer, the stipules are a lot more conspicuous than the stipules over here in showy tick trefoil. These are lomens right here. So this is what a lomen is. A lomen is an indehiscent dry fruit that becomes segmented. As you can see here, these little segments form around the individual seeds in each of these, and then this fruit will break apart on its own, but it doesn't split open like a legume does. And you can see there's a little bit of a difference in the lomen here. These look like they're a little bit more slender maybe. There's a big difference in the lomens between panicled tick trefoil and these 2 over here. Much more angular, where these are rounded on the bottom side. These are much more pointed. So that's a good way to, again, distinguish this one from these 2. The other thing I'll say is up here, what I've noticed is, and you can kind of, if you blow this up, if you can somehow blow it up a little bit, you'll see that the mid veins on these leaflets here has got sort of a shiny surface coloration to them. I've always noticed that on most of these Desmodium paniculatums, that the mid vein often is kind of shiny. All right, what we got left here? That's it. Right on time. That's why I didn't put any more in. All right, are there any questions?
I don't see any right now, but if anyone has a question, feel free to put it in the chat, or at this point you can unmute yourself if you prefer to.
I will say something right here. If you think that these little color splotches in the banner might be helpful, no, they're not really, because the same things happen over in these other species too. You can see them here as well. You can't quite see these as well, but they're there. They're kind of hiding behind. You can kind of see them right there. You'd think, oh, that might be something that would help separate the species from each other, but it doesn't. All right, well, what's next week, Lance? I forget.
We're off next,
Oh, we're off next week. That's right.
and then
Yep, that's right. Taking a break.
yep, 24th
So-
is plant evolution and diversity.
Okay. Well,
You got
thanks
a
for
question?
coming, everybody. I'm gonna, I guess, stop sharing and I can see a few faces maybe. Thanks for coming. Hope you learned some things. Unfortunately, I couldn't cover, Astragalus, Lespedeza, Dahlia very much, or Baptisia, but maybe in a workshop. One of the next workshops I'm going to be doing will be on Fabaceae.
Tom, we do have one question now.
Okay.
What exactly is different about the seeds between the two senas?
Oh, what's the difference about the seeds between the two senas? I'll have to look that up. It's their shape, I believe, and it's it's something it's nice to have a picture of, because it's the shape, and I can't remember exactly what it is off the top of my head. But whomever that is, if you want to send an email to me, by the way, I should put my email address on the first slide, but it's really easy. thomas.rosburg@drake.edu. I can get back to you on that. I just don't have to remember what it is. But that's what I had. I had some people down at the Nature Conservancy, Elizabeth Owen and Dale Maxwell, send me some seeds of senna that they were worried, or we were concerned about, or had some worry, because Hebecarpa has been seen in southeast Iowa, and I wanted to check and make sure whether it was Hebecarpa or not. She sent me some seeds, and it's not. It's the native one.
Okay, one more. What's a good way to separate Astragalus and Oxytropis vegetatively?
Vegetatively, well, probably the best way is that most Astragalus are going to probably, well, yeah, it kind of depends upon the species. I was going to say eventually would have a colline, stem, would have a stem with some leaves coming off of a stem. Canadensis does for sure, of course. Lodiflorus does have, I believe, a little short stem. Crassicarpus may not, so that may not work very well. I'm thinking that I'd have to go back and look at it. I mean, for me, and this is what's hard to convey, it's sort of this gestalt thing, that it's like why I can recognize two different people, that look alike. You just see things that you have in your memory that tells you what it is. I think it might be to some extent on Oxytropis lambertii, which is again the only Oxytropis we have. I think the leaflets might be a little bit more pointed looking. We could go back and look at it real quick here. I've got an Oxytropis picture here. Yeah, I think maybe that they're more slender. The leaflets are more slender, more, you might say, almost a little bit more linear than the leaflets on Astragalus in general. But I'm just kind of trying to think off the top of my head here. Sometimes it's hard. That's why. Yeah.
Hi.
Hi.
So you mentioned the non-native senna
Mhm.
was in Johnson County. Did I hear that correctly?
I heard a report. I don't someone emailed me, and I'm pretty sure it was someone from Johnson County, who said they thought that they had it on some property that they manage. I can't remember
Okay,
who that was. You know, it was like a year ago or 2 years ago.
okay,
So there's a potential that it is. If you look at the bone map for it, it is a native species in Illinois. And I believe it might be native in Missouri too. So
yeah, I was
Iowa,
wondering if it was Missouri.
I believe it is. Iowa would be on the very northwest edge of its range if it was native. So what my concern has been with it is that most of us, I think, whenever we are out and we see senna, assume it to be Marylandica, because in Isles and Rosa, that's the only one we have, right?
Right,
So that's all
right.
we have. Well, what if we do have senna hebocarpa native, and it just got missed all these years because they do look awful lot alike. You have to
Interesting.
have seeds, or you have to look really closely at those extrafloral nectary glands on the leaves, on the leaflets, and or the style and the hairs on the style to separate them. So what if, what if there is some hebocarpa in the herbarium at Iowa State that's misidentified? Unfortunately, I've not had the time to go back or take that task on and go through all of those and look at that. And Deb has not either, I don't think. So I don't think that's the case, but that's a concern.
Yeah. Well, if someone does find it,
Well, the thing is, if
where it's located may help with that, as well as the herbarium.
Well, I mentioned it because any of you who are out and you see senna, and senna is pretty easy to recognize, of course, it would be good to try to get some flowers or leaves. You need the entire leaf really to see those nectaries. And if you can wait and come back and get the fruits with some seeds,
Right.
that would help a lot, because I feel like we should be looking at that really just to see for sure what's going on there.
Okay, thank you.
We got a couple more. What vegetative characteristics do you use to differentiate Vicia and Lythris?
Between what again? Sorry.
The
Vixia and Lathyrus.
Yeah. Yep.
So Vixia and Lathyrus, if you go back to that, I'll share the screen again real quick. So again, in Lathyrus, you use these stipules. So look really good at these stipules here. This one here is in Plustris. This one here is Venosus. They look pretty similar, but there's a little bit of difference in their width, as I said. These are more narrow. These are more wide. If you look at Vixia, here's Vixia right down here, Vixia americana. Vixia has these two big teeth, you might even call them lobes, that come off the lower bottom side of the stipule, so the outer edge. See them there? Those are always there in Vixia americana. And I don't know if other Vixia have them or not for sure. I can't say for sure, but Vixia americana, that's how I do it. Vixia americana always has these stipules that look just like you see right there.
Okay, someone's curious about the flowering time of the false fragrant indigo. Is it similar to other Amorpha species?
Let's see. Well, I think it's pretty close, but I'm not so sure. I can't say for sure off the top of my head. That's easy to look up, of course, but I don't have really anything at my fingertips here where I can look it up. I think it's probably pretty close, but what I would say probably is, off the top of my head, and here's just how I would think about this, is that because Amorpha fruticosa is in wetter soils, damper soils, my expectation would be that it might bloom a little bit later. Because what happens in wetland soils is it takes longer for the roots to warm up. Wetland soils are wet. And so there can be water, there can be water standing there can be saturated soil, and that water has high specific heat, and so it takes a lot of energy to change the temperature of that water and change the temperature of those soils. So prairie soils where Amorpha and Canescens are going to be growing are going to warm up a lot sooner. So just on the basis of that, I would expect there might be a difference. Now, if on the other hand, fruticosa has adapted to deal with that, then all bets are off. But I'm just thinking, I think I generally see it probably just a little bit later, I think, than the other two. But if anyone knows, chime in. Discussion.
Okay, I posted your email in the chat.
Oh, good.
I think
Yeah.
we'll
Yeah,
call
you
it
always
for the
welcome
night.
to send me an
but-
email. And I can't guarantee I'll get back to it, within an hour or two, but usually within a day, and get back to you. Well, again, thanks for coming tonight, and hope you learned something about Fabaceae, a great family, important family to have in all of our systems, and there's lots of good species out there to discover and see. See you in 2 weeks.
Yep. Thanks, Tom. Thanks everybody for joining.
Bye.